We're going to take a derivative of a function. This function, though, is a function of x, and it turns out that x is a function of time. So we're going to need two rules here. We're going to need to look at how to take a derivative of a polynomial, but also how to take a derivative if there's a function of something else in there. So, black pen. Let's take the derivative with respect to time of the function. And that would be the derivative with respect to time of 5x squared minus 7x plus 3. So to do that, let's first take the derivative of the first term. First term is 5x squared. So we have to take the derivative of 5x squared with respect to x, and then the derivative of x. So the derivative of 5x squared, there's a 5, and then we take the exponent 2 out front. And then x to the x squared becomes, the new exponent is 2 minus 1, so that would be a 1. And then that's it for that term, but we still have to take a derivative of x with respect to time. Looks to me like a velocity. We don't know anything about that velocity, so we'll just leave it like that. And that's it for that term. The next term is 7x, the derivative of that. There's the negative 7 out front. X is really x to the 1, so when we take a derivative of that, we take the 1 out front, multiplied by 1, and then the exponent becomes x to the 1 minus 1 is 0, so that's x to the 0, and then we do the derivative of x with respect to time. And then that's it for that term, and the last term is a constant, so the derivative of the constant is 0. So let's rewrite this. 5 times 2 is 10. X to the 1 is just x. And then dx dt, if we knew something about the velocity, we'd probably write it as a velocity. And that's it for that term. And then 7 times 1 is just 7. X to the 0 is also 1, so I won't bother writing that in. And then dx dt is, again, a velocity, probably. And we'll just leave it like that. And that's our answer.